This conference will now be recorded.
Fine, guys. So yesterday I was giving you the overview on the performance engineering, how it is going to be part of your development lifecycle. What is your role and responsibility throughout the lifecycle? What are the various activity we will be doing as part of the performance engineering is what we saw yesterday, right? And I was also giving a overview on each of the topics that we are going to cover as part of this current batch. Correct. So what we'll do is we'll get started with the day one. As I mentioned today, um, before going into the performance engineering topics, uh, I would like to probably make sure that you're getting comfortable with these terminologies, concepts of Java, JVM, and get a little bit exposure to the Java programs, very specifically from the engineering point of view, not from the development point of view, more from the engineering point of view. Okay. So we'll get started with these basics, and once we are comfortable with this, we'll go into the engineering sessions. Okay, and again, if you don't have any background on programming Java, don't worry about it. The way I'm going to teach you is, um, it's going to be very simple, and the way you will be able to learn these concepts. We are not going to do any hardcore Java programming. We are not going to be developing applications. No, just for us to get an hands-on on few things, so that you will be able to comfortably do analysis and then go and talk about these recommendation to the developer. Only from that point of view. Even so, which means if you don't know anything about programming Java, don't even worry about all these things. Okay. Fine. So, what are the prerequisite for you to run any Java application or create any Java application? You should have a Java, right? So, if you don't have Java, please install Java in your machine. Okay, you can download the Java from Oracle website. Java 8 or any version more than 8 is absolutely fine. Okay, to find out in your machine if already Java is there, go to the command prompt and then type Java-version. Okay, so it will give you what version is available in your machine. Okay, if you don't have it, install it from the website and then you try it again and then find out what version, whether the version whatever you installed is properly getting reflected or not. Okay, so when you install Java, right, there are either you can install JDK or your JRE. Okay, the difference is JDK is kind of a superset. It will have your libraries, compilers, everything that is required for a development. Okay, if you're going to develop applications, if you're going to create programs, if you're going to use Eclipse, you need JDK. Okay, or if you're going to only use Java for opening the Java application, running the Java application. For example, if you want to open the Jmeter, you need JRE. If you going to just deploy your application in Tomcat and run it, you just need a JRE. Okay, so JDK will have everything, including JRE plus compilers, debuggers is your JDK, and JRE going to comprise of your runtime libraries, runtime execution libraries, plus the JVM itself, Java Virtual Machine itself. Okay, so JDK, JVM, JRE, you might come across these terminologies here and there. JDK is the top layer, which will include everything from a development plus JRE, and your JRE is going to be your Java runtime environment. which means for running your Java application, you need JRE. And inside that, you have a Java virtual machine in which your application is actually going to run. JVM is the one which is going to take care of your application getting executed. Okay, if you go into your folder wherever you install Java, right? For example, in my machine in C, if I go to program files and go to Java, I will have the JDK. Inside JDK, you will have bin configuration, all these things. If you go into, so which means this entire folder is the JDK, right? You'll have the libraries, all these configuration, everything. If you go into bin, here you will have, say java.exe will be there, java.exe will be there, and then you'll also have other libraries like jconsole, jmap, jstack, all these things we will be using it later for taking the heap dump, thread dump, Java monitoring. All these things are going to be available inside the bin. Okay, so if you go to jmap will be used for taking the heap dump, and then jstack will be used for taking the thread dump, and then you will have jconsole for taking for monitoring the your Java application, right? So for your JVM, in fact, monitoring the JVM. So all these things are going to be available in this library. And then if you go to server, you will have the actual JVM.dll, right? So JDK is your entire directory, and then if you go inside bin, you will have java.exe, all the command, all the tools for getting thread dump, heap dump, monitoring everything, and inside server you will have a JVM. Okay, and also in your bin, you will have your uh, okay, I'll come back to that later. Okay, so that's how the structure is going to be. In JDK, your JRE, JDK, JRE, and then JVM. Okay, so for you, uh, you can install JDK when you install Java, right? Um, so that you can practice some of these Java programs. Make sure that you get a JDK in your machine. Okay, and one more thing is once you installed Java, just go to this environmental variable. Okay, so once you install Java, you should tell your machine where the Java is installed, right? So normally the environmental variables will be set automatically when you install Java, but just to make sure that, right, you go to environmental variables, okay, and then you should have Java and then Java Om. Okay, so if you don't have it here, just create a new Java and then give the your entire wherever you have your java.exe is there, right? That path you give it. Still, till /bin you give it. Okay, wherever whichever directory it is, Java JDK bin, that is for Java, and then one more you can have it for Java Om. Okay, and Java Om you can just remove the bin. You're saying where is your entire Java directory present. Okay, for that you can just give it still JDK. Okay, so Java to say where is java.exe, that will be /bin, and Java Om is for JDK. Okay, both these things you need to add it, Java and Java Om, and then there will be something called path. Okay, go to the path, and then here as well provide the java.exe path, which is your JDK/bin. Okay, so if it is not there, add a new entry here. Okay, so three things. One is Java, Java Om, and then in the path you enter the again the Java directory. Okay, once this is done, you click OK, come out of this, and then open a new command prompt, and then type in Java version. This will make sure that you have installed the Java, your environmental variables are set properly, and then it is getting reflected. So hereafter, whenever you open the Jmeter or whenever you open any Java application, it should be able to go and pick the Java version from this particular path. Okay, yeah. So,
Uh, JMap is for the thread dump. Uh, can you just repeat that around JMap and JStack?
okay, you don't need to worry about it for now, but yeah, JMap is for heap dump. Okay, JMap is for heap dump. JStack is for thread dump.
Okay.
Okay, yeah. You don't need to remember about this. When we go into the sessions, you'll get to know about how to use it, when to use it, all these things. Yeah, these are the two things: JMap for heap dump and JStack for thread dump. Okay, yeah. Um, so the Java programming, right? The way we will learn, we'll try to learn, will be a kind of a reverse engineering. Okay, see, normally when you go and if you're a beginner, right, if you're a college student, then normally what we do for Java or any programming language, we go via book. We look into your variables, data structures, your oops concept, and then your expressions. That's how we go and learn chapter by chapter, right? Now you are all experienced professional. You're either into some domain like testing or other domains already. So now going by book is not going to help us, will not going to give us any motivation in getting this learned in a very faster way. Correct. We might not even have time to do that. And again, for our objective, where we are not going to learn Java from a development perspective, more from the awareness, more from the getting comfortable with few things, right? So I would say that we have to go and create programs and then learn what is there in the program. For example, if you want to go and connect to we need to write a Java program to do a DB connection. I want to write a Java program for making an HTTP connection. I want to create a program where I can go and call um, a reusable program like a calculator, or I want to read a CSV file, I want to read a JSON file, I want to write a CSV file. So the best way to learn Java program at this stage of career, right? We are not again, we are not going to be a not going to be a developer, right? For us to get started with some hands-on, that would be the best way. Okay, so what we'll do is we'll try to understand the program skeleton first. What will be there in any Java program, and then try to go and create some program on our own from Eclipse. Okay, so any program, any Java program, be it is a very simple or a enterprise-wide Java application, you would see these things: class, object, method, package, imports, and data types. Okay, um, so you go and write a program. A program is going to um, accept some input. It is going to do some processing, and then it is going to return the output. That is a very simple input, processing, output. Um, any program is going to do, right? So when you write a program, say I need a program to add two numbers or subtract two numbers, right? So you need to um, get those input and then store it temporarily, right? I need to store A, I need to store B to add A and B. Correct. So for storing those input variables or output variables, you need to declare few of these data. Right? In Java, there are two types of data types: uh, primitive and non-primitive. Okay. Uh, uh, the primitive and non-primitive, they have classified such a way that the primitive is going to the data that is getting declared as primitive, like integer, byte, character, boolean, all these things are all going to occupy very small space. Okay, whereas non-primitive is going to be your strings, arrays, objects. It's going to occupy more spaces. There is much more relationship between primitive, non-primitive. Okay, when we go into the memory section, memory topic of a Java, we will get to know more in detail about primitive and non-primitive. Okay, what's the difference between primitive and non-primitive? where is the primitive going to get stored, where non-primitive is going to get stored. Right, all these things we learn in detail later. For now, for our simplicity, you can declare integer or a byte or a string in a program. Any program, some kind of data declaration is going to be there. Okay, and you're going to write a program for adding two numbers, right? A plus B. So you declare A, you declare B, and then you write a one line of code where sum C is equal to A plus B. Okay, and C also you need to declare because it's the output variable. Right, and then when you save it, that is what you call it as a program, right? When you save in Java, it is going to be saved as .java. Okay, you're a simple program where you declare three variables A, B, C, and then when you do an addition, sum of C equal to A plus B, right? That is going to be saved as .java, and then when you compile it, when you compile the program, that is what you're going to call it as a class. Okay, a class is nothing but a compiled version of a Java program. Okay, so in any application, you're going to have multiple such class files. Okay, you can think of in the e-library application what I showed you yesterday. You can think that login is going to be one class file, view library is going to be one class file, add library is going to be one class file. So logically, there are going to be multiple functionality for which there is going to be multiple class. Okay, so inside the class file, all your operations, instead of your operations are going to be written one by one or consecutively, logically we will group it into a method. For example, addition will be a method, subtraction will be a method. It is kind of grouping it. Okay, so I will write a program for addition and I will say that it's an addition method. Then I'll write a program for subtraction, I'll call it as a subtraction method. So one class file can have a multiple operations or multiple methods. Okay, method is a actual piece of group where your actual processing is going to happen. So in a class file, if you look into a class file, you will have a data that is getting declared on the top, and then you will have method A, method B. Method A will do some operation, method B will do some operation. Okay, method is nothing but a set of instruction which is going to do some operation. Okay, so in a project, right, say in a e-library itself, there are going to be multiple classes, right? Let me also go and open it in parallel and show it to you so that you will understand the structure as well. If I go here, somehow my e-library project got removed from this workspace. Um, okay, if you see here, right, your e-commerce is my Java project, right? And then you have a multiple Java files, price.java, product.java, right? You have two Java programs, right? And then a compiled version of that is the your price class file, and then product class file, right? And then these two are grouped under a package called e-commerce. Okay, so again, it is going to be a logical grouping, right? Multiple class files will be grouped under a single package called e-commerce here. So any application is going to have multiple class files, and then class files are going to get grouped into a package. Okay, so from a skeleton perspective, you're going to have a class, you're going to have a method, we are going to have a package, and then you're going to have primitive and non-primitive data types, data declared in your program, and you're going to have something called import. Import is so you don't need to write every program by yourself, right? There are going to be some reusable programs that will be written already in your organization, or you're going to have something available over the internet which you're going to download. Okay, so you will import a lot of such jar files or reusable programs in your application. right? The developers normally go and import lot of libraries, lot of jar files, either from the internet or from the other teams in the organization. Okay, so when they do that, right, they have to use these import. For example, let me go and open a project where I might have a import. Yeah, for example, for connecting to the SQL database from Java program, I need all these import. Okay, so the typically what happens is you download your jar file for connecting to the database from the internet, and then you go to the Java programs. That's how the developer will do. I'm just showing what he's going to do from an import perspective, right? As I said, he's not going to write every program, every lines of code on his own. He will write some code logic, but he's going to reuse the external libraries from internet or from the his own organization, okay, to connect to a database, to parse the JSON files, to parse the your CSV files, to write into a CSV file, or to make an HTTP connection. So for various activity, there are going to be the jar files that you need to import. Okay, so you will go and import it to this. If you go to the Java build path, okay, and go to the class path, you will download it from the internet, okay, and then or from the his own organization repository, and you will add it to this particular path. Okay, so you will just import it to these. You will go here and then add the external jar file. Go to that particular folder where the jar file is there, and then you will add it here. Okay, so import is, so any program if you take it, there are going to be a lot of imports. From a skeleton perspective, you will have import, you will have class, you will have methods, you will have data that is getting declared. That's how the any Java program is going to be. You take it one simple project or an enterprise wide project. That's how this skeleton is going to be. Okay, now coming to the object, right? You might have heard about the object, the definition of object. If you already know Java, you might have already know about what is object, right? But let me try to give a simple explanation. It might not be a very technically correct or perfect definition, because the perfect definition is always a little bit confusing. So just for you to understand it in an easy way, I'll explain with an example. Okay, so let's take an Amazon as an application, as an example for our this definition. Okay, so we have Amazon.com. You as an end user, you open the Amazon.com from your Chrome browser, and you're going to purchase a laptop. Okay, say Lenovo laptop, and then you go to the particular product page, and then you will go and select a Lenovo laptop, quantity as one, and you'd like to get the price, right? Similarly, I as an Amazon.com user, I'll open the Amazon.com from the browser, and then I might be wanted to purchase a mobile, right? Maybe a two Samsung mobile. Okay, in a Java application, in your code, there might be a say one class file called price calculator. Okay, price calculator is a common class file for any product, right? It will accept a product, it will accept the quantity, and it will return the price. There's going to be only one class file for price. Okay, while you are going to request a price for laptop, and I going to request a price for the mobile, the runtime, your Java application or a JVM will create a price calculator, a duplicate of that price calculator for you, and then one more duplicate price calculator for me. It is going to create an instance or a duplicate for you and for me. And similarly, there are 10 people, 20 people, 100 people who are going to call the similar functionality from their own browser, right? So for every such invocation, a duplicate of that price calculator class file is going to get created. So an instance of a class file or a duplicate of the class file is called object. This object will get created, okay, and then for in that object, the variable that whatever that has been coming for you, right? It will be laptop for you, and then quantity S1, and then the price calculation will happen, and then it will and JVM will return you the price. For me, it will be for mobile, and it will give the price for the mobile. Once it is done, that object will get deleted a little later. For me also, for that object will get deleted later. So object is a temporary instance, temporary duplicate of a class file that will be created at the runtime. So which means just think of there are n number of functionalities, n number of users are going to access it. So the runtime, there are going to be many such objects that are going to get created and destroyed, Okay, so object is a instance or a duplicate of the class file that will be created in the runtime. Okay, and as I was mentioning about created and deleted, right? That is the core part of the when it comes to memory pattern, memory leak, object getting stored in the heap. All these things are something we will learn it later. But nature of that is these objects are nothing but an instance or a duplicate of the class file, which will be created during the runtime, and then it will be deleted after some time. How it will get deleted and all, we will learn later during the JVM, during the memory topic, memory leak topic, or GC. We will learn a lot about it. Okay, but yeah, that's how your Java program skeleton is going to look like. A class is nothing but a compiled version of a Java program. In a class, you're going to have multiple methods, and then you're going to have objects, you're going to have packages, you're going to have imports. Okay, what we'll do is if you download, you can download the Eclipse from my drive, or you can also download it from the internet. Either way, it is okay. Okay, so once you download the it will be just a exe. Okay, once you download that Eclipse into your drive, just double click and open it. Okay, once you open it, right, your Eclipse will not have anything. It will have any, you don't have any projects, or it don't have any files, right? So what to do is, for to make sure that your Eclipse is working fine or not, just go and create a new project. Okay, go new. See, this is nothing to do with the performance engineering as such. Okay, again, this is just for you to in engineering. When you go into the memory leak analysis or response time analysis, CPU profiling, all these things, right? We will be looking into which class is taking more time, which method is taking more time, which object is having a leak. And when you look into your AppDynamics or JProfiler, right, it will provide you the root cause in a way. It will point to a package, class, method. The structure of the your analysis will be package dot class dot method. That's how it is going to be coming out in JProfilers or AppDynamics. Okay, so you should not have you should not it should not, all these things should not be a black box for you. So you should know what is package, what is method, what is class file, and visually as well. If you at least done once some kind of hands-on, right, or at least if you listen to my teaching on these topic, then when we go into the engineering sessions, when you learn about these things, you will be able to visualize, okay, this is how it is going to be. So it should not be a black box for you. That is why we are learning this. Okay, so if you want to do an hands-on in Eclipse, it's very simple. Again, just try to spend 2 hours, 3 hours whenever you get time in the weekdays or weekend, not more than that, right? So you download the install Eclipse from my drive or from the internet, okay, and open it, and then go to the new and then go to the new project, Java project, click next. just type in whatever name you want, right? I'll say that September weekend. Okay, and then say next. Finish. Okay, once that is done, okay, just go and if you expand this, you will see a source folder, you will see a JRE system libraries. Any new project you want to create, it will add the system libraries by default. Okay, right click it and then go to new, and then let's create a first file. So go and create a new class file. You can just give whatever name you want. You can give hello world or first program, whatever you want. Okay, and just don't forget to click this public static void main. Don't worry about what is public, what is static, what is void, what is main. Nothing applicable or nothing relevant for us to learn this from our engineering perspective. What this means is when you run your Java application, it will look for a main method. Somewhere it has to start, right? Your project will have the September weekend might have multiple classes. It should know where to start. So one of your class file should have a main method. So when you create a first program, just make sure that you turn on this. Okay, once you do this, okay, just come here, and then what you do is you just go and add a print statement. Okay, just to make sure that your program is working or not, your Eclipse is working or not first time, right? So you should pick the Java version properly. So just go and enter the system.out.println. It will write just print your message to the console. Okay, save it and then right click it and then run as Java application. Okay, it will say it is I am here. Okay, this means your Eclipse is working properly. It is able to compile it. It is able to execute it. It could able to pick your Java path properly. Okay, it's very simple. First hello world kind of a program. Correct. Now, what we'll do is we'll look into two examples. Okay, one will create just one class file with some operations, and then we'll create two class files and then see how to call from one class file to another class file. Typically in your application, you are going to have multiple classes, and from one class files, you will call another class file. From another that class file, you will call another class file. That's how your hierarchy is going to be. For a login or for any functionality, it might call multiple classes internally. And when you look into JProfiler or AppDynamics during analysis, right, you will see that kind of a structure as well in the analysis. When you troubleshoot a response time problem, or when you troubleshoot a memory leak problem, okay, the analysis in the JProfiler or AppDynamics will show the this tree structure. The tree structure is from where the call started, from which class file the call started, from there where it went, from there where it went. That's how the structure is going to be. Okay, so from that point of view, we just will go and create one class file and another class file and see how from one class file another class file is getting invoked. Okay, let me go to the existing program. Okay, um, so in this program, again, it's a very simple program where I have a main method. Okay, and just printing it. Okay, and I have two integers declared. Okay, value 1 and value 2, 12 and 10. And then I'm just doing addition, very simple addition, sum value 1 plus value 2, and then I'm just printing it, nothing else, no complication, nothing. Inside a method I have a addition operation, and then I'm printing it. Okay, I'll just go and run this. Okay, so I think something is not commented. It is going to the second program. In fact, just give me 1 second. I'll just save it properly. I looks like it is not getting saved properly. That's why. So I'll explain you. Okay. See, I commented few things. I don't know why it is not it's not getting reflected. But if you see here, this addition I can do it directly here. Okay, I'm giving two values, value 1 and value 2. I'm adding it and then printing it. Okay. Now, if I take this out, what I'll do is I will do the same thing, but I will use two programs to do this. Okay, I'll comment this out. Okay, so in this first program, I'm just declaring your two variables, int1 and int2. Okay, I'm not doing addition in this program. Say, for example, in your organization, somebody has written a calculator class file, or there is a reusable class file already available for your calculator. Okay, so here in the second program, say it is a calculator program, you will have one method for addition, one method for addition, one method for subtraction, one method for multiplication. Okay, so this is the second program with three methods: addition, subtraction, and multiplication. Okay, what I'm going to do is from the first program, I will pass on these two values to the second program, and then ask the second program to do addition, and then return back the output. Okay, so I to do that, I cannot call the second program directly. Okay, first I have to create a duplicate of the second program, create an object for the second program. Okay, so typically from one class file to another class file, when you wanted to call any methods, this is the syntax for creating an object. Let's not worry about the syntax, why it is written like that. We don't need that kind of understanding for our objective. Okay, it's class file, any object name equal to new the class file name. Class file name is second program. Okay, so class file name, any object, any name you can give it, my object, obj1, obj2, anything you can give it, new of second program. And then using this my obj, okay, my obj dot add. There are, if you go and type in, say, I'll remove it. If you go and type in my obj dot, it will show you whatever that method is there. Add is there. You will see subtraction. You will see multiplication. So it will automatically, it will say that there are these methods available in your second program. So I'll click add, and then value 1 comma value 2 automatically it takes. Okay, so which means I'm calling your second program to do passing this value, and the second program, this value 1 value 2 will be received. Here it will do this addition, and then it will return the value, return the sum. This sum will go into the first program. Okay, so from one class file, there will be multiple class files in your application, in the application which you are going to work, right? The first application will call the second application through an object, and then it will call the method, and then things will get executed, and then it will return the response. Okay, so which means when you look at the response time and all, overall response time for a login, it will say 10 seconds. And then when you look into the time which taken for that particular 10 seconds, it will point out that, say, this main method is taking 10 seconds. Then if you go and troubleshoot, then it will say that it took time in this addition method, which is part of the second program. And then when you go to the second program, it might call a DB call. It might call a third party call. So that's how the structure is going to be. From it will start from somewhere. It will go to second program. It will go to third program, and your hotspot or your performance problem could be there in the third program or fourth class file, a particular method. That's how we will troubleshoot when we go into the AppDynamics or JProfiler, right? But programmatically, that's how it is going to get structured. It will have a package. It will have multiple class files. From one class files, another class file will be called. From this class file, another class file will be called. Say from this class file, there will be a DB connection, making executing some queries. That's how any program is going to be structured. Okay. I'll take a pass here, guys. Anybody have any questions, not only on this, in general about the topic, about the courses, about the course content? We can probably spend another 10 minutes. What I will do is, these Java programs are also going to be available in the drive. Okay, but if you guys are really wanted to take it seriously and then wanted to learn performance engineering, just try to create these small programs. Okay, you can create your own requirement also. See, with the now GenAI, power of GenAI, right? If you go to chatbot and then ask chatbot or ask the ChatGPT to give you the Java program for anything, it will give you, right? Say I want to connect to a database, it will give a code. If you want to go and do a parsing your CSV file, it will give you the code. Everything it will give it. You just need to copy it and paste it here, and then try to see how the code is written, how the code is structured, what are the functionality that are used. That is the best way for you to get hands-on or learn Java in a very easy way, rather than going from a book chapter topics and all. It is too late for us to do it, since we are already working in a project, working in a for a organization. We will not get that time. But for you to get little bit comfortable, just spend 3 hours, 4 hours, not more than that, in Eclipse. Create some programs, create some class files, so that you will have very comfortably. You can go to a developer when you go and report a problem or talk about the recommendation. You will be able to go and convey the message very confidently, because it is not going to be black box. You know what is that you're going to speak about. Okay, so what I will do is, these things are already available in the drive, all these programs, and I'll also ask the team to probably upload a detailed video about the other Java programs as well, how to connect to a database, how to connect to do an HTTP connection. That as well, I'll ask the team to upload the video in the playlist. Okay, I'll pass here. Any questions, feel free to ask.
Suppose in DB side, like we have written a program to fetch some data. So as after that, if it waits for some other third-party application to run, so it will wait for some time. So will JA Profiler able to provide information for third-party things also, like if there is any slowness from that side, or how it is?
It will say that this HTTP call is taking 3 seconds or 5 seconds. Okay. See, you are profiling there's application A, there is an application B, and you're profiling the application A now. Okay, you've installed JProfiler in application A, and then you are opening your browser, you're going through that functionality, and then in JProfiler, it will say that a particular method is taking 0.5 seconds or 1 second. It will say that DB queries are taking 100 milliseconds. It will say that there is a HTTP connection made to application B. It took 2.5 seconds for the response. That JProfiler will say. Why application B is taking 2.5 seconds? You will not get an answer here. For that, what you have to do is, it can be it can be a web application, it can be a web services, right? The application B can be a web application, or it could be a web services. So if you wanted to troubleshoot the 2.5 seconds, then you have to go and install JProfiler in the application B also. Not only with JProfiler, even for AppDynamics or Dynatrace, that is how it works. When you install AppDynamics or JProfiler in one application, it will give you the complete visibility on that application. and then it will say that there's an external call going into an application B, which is taking 2.5 seconds. But you will not get a root cause for why it is 2.5 seconds. For that, you need to install the Java agent for AppDynamics or JProfiler in the application B also. Yeah, that's how it works.
Okay. So, is there anything that that cannot be done in JProfiler? Is there anything like that
And it cannot be done.
in using
Um,
JProfiler? Uh,
See, any Java applications, be it as a web application or a microservices, you would be able to profile, and then you would be able to get into the root cause of which method, which DB call, which object is having a problem. So as such, when we cannot generalize it, but yeah, it will give you what we required from a profiling perspective. Any your kit profiler or J profiler, everything is going to do the job what is required from a profiling angle.
okay.
Yeah. There's also one more video that will get added tomorrow, that is for setting up this e-library application. Okay, again, it's very straightforward only. You download the Tomcat from the drive or from the internet, and then go to the web apps. Okay, and elibrary.war will be there in the Google Drive again. Okay, you download that war file and put it in the web apps, and then go to the bin directory. Okay, and then go to the catalina.bat file. Just ensure one thing, and then go and do a startup. Go to this edit with notepad. So this file is where we will provide the heap configuration and all during the memory session. Okay, here just make sure that there is no directory related line items. Okay, because this directory belongs to my laptop, so you can comment everything else if it's not commented. Okay, to comment out, just put rem, it will get commented. Okay, just comment out all these lines where there is a C drive or D drive. Okay, that is alone you ensure, because otherwise your server will not start. Okay, so there will be a line for the heap configuration, that you let it be as it is, and from there next 7-8 lines, wherever there is a line for with C drive or D drive, you just comment it for now. Later I will tell what to do. Okay, then save it, and then go to the bin and click this startup. Okay, it's very simple step. Download Tomcat, and then download the war file, put it in the web apps folder, and then go and double click on the startup. Okay, I'll anyway with a little bit more in detail, I will add a video for that as well. So follow that, and then get it set. When we come to the next class on Saturday, make sure that you have the Tomcat available in your machine, e-library application. Once it is started, right, you just go to the localhost and then type in uh, localhost 8083 and e-library. Okay, it is, I think, still getting started. Okay, anyway, you refer to the video, very simple steps, and then you just remember that it is EL caps. Okay, I mean that's where I think we usually make mistake. It is E caps, L caps library. Okay, so next before the next Saturday, make sure that you have Tomcat E library is installed, and then Eclipse if possible. If you are it's not mandatory. If you have time, install Eclipse, and then write few programs as well, what we did today. Okay, that's a minimal thing that I would need you to do it before you coming to the next class. Okay, we'll stop it here, guys. If you have any questions on the course content, you can ask the questions. If you have any questions on the payments registration, you can reach out to Kumar sir. Okay, yeah, or tomorrow or day after. Still, if you want to have a call with me to discuss on whether it is applicable or not for you, um, or regarding the course content, feel free to call me. We can discuss based on our mutual availability. Okay, any questions, guys? Put it in the chat or feel free to ask. Okay, if there is no questions, guys, yeah, feel free to put a message in the WhatsApp group. We can connect later as well, or we'll meet next week. Yeah, thank you, guys.
Thank you, sir.
Yeah, thank you.